Hello everyone. Today we will talk about a problem called removing the kth last element from a list. Let's begin with the problem definition. We are given a singly linked list and an integer, k. The aim is to write a program to remove the kth last element from the list. Pay attention here. We should remove the kth last element. This means the kth element from the end, not from the beginning. For example, let's say we're given the singly linked list L, which has 5 nodes. If k equals 2, this means you should remove this one, which is the second to last node. As we all know, in a linked list, if you want to remove a node, you can achieve this by linking the previous one with the next one. In other words, if we want to remove this node, we can link the previous node here with the next node here. But before we address this part, how can we find this node? It's not very difficult to come up with a brute force solution in this case. We can compute length first, and then try to find the kth last element by finding the length minus k node from the beginning. Very simple mathematics. This solution can solve the problem, but there is a drawback. It entails 2 passes of the data. If the amount of data is very large and stored on the hard disk, we'll need to access the disk twice, which is very slow. So let's look at a better solution. Here are 2 pointers. First, we let the first iterator advance by k steps, or in other words, move the first pointer k steps. For example, here the k equals 3. We move iterator 1 3 steps to here, then we move iterator 1 and iterator 2 simultaneously. When iterator 1 reaches the end of the list, iterator 2 will point to the k plus 1 last node, which is the previous node of the target node. Finally, we use the operation we mentioned earlier. Remove the target node by linking its previous node and its next node. Very simple. Here is the code for this algorithm. Be aware we used a dummy node here because it's possible that the target node is the header or the first node of the linked list. To deal with this situation, we need to use a dummy node, in case of modifying the header. The code logic is as follows. First, move the iterator 1 k steps, then move both iterators simultaneously, 1 step at a time. As we discussed earlier, when iterator 1 reaches the end of the list, iterator 2 will point to the target node's predecessor. Lastly, remove the kth last element and return the header of modified list. The last topic to cover is complexity analysis. Compared with the first brute force solution, the time complexity of this algorithm doesn't improve. Theoretically, they are actually the same, O(n). But the second solution only uses 1 pass, so it would perform better in most practices. For the space complexity, since we didn't use any extra space or any data structures here, it would be O(1). That's it. Thank you.
If you found this video helpful, BitTiger Pro has a comprehensive series of videos covering all the skills you need for the coding interview. We explain the latest technical interview problems used by top companies like Google, Facebook, and Microsoft. Subscribe to BitTiger Pro and get access today.